Students, let's measure some line segments, shall we? Let's take a look at this one on the number line. What is the length of UV? Well, UV is a line segment because it has two definite endpoints. We have U with a closed circle here and V with a closed circle there. So that means that this is a definite line segment. It does not extend forever. But how long is it? Well, you can see on the number line that it starts at -2 and it ends at 7. So we might think of combining these with addition. You'd say, well, -2 plus 7 equals 5? And you say to yourself, well, that can't be. It can't be 5 because 5 is from 0 to 5, right? From 0 to 5 would also be a length of 5, and UV is longer. So what is unique or quirky happening here? Well, line segments are always positive. Right? We haven't slipped into a black hole of oblivion. All right? We have positive line segments. You don't say, for example, oh, how long is it to the store? Oh, it's about, -2 kilometers, give or take. Like, we just don't say that. Line segments are always positive. So what you need to do if you see a line segment on a number line and there's a negative component is to take the absolute value of it. So from -2 to 0, well, that's -2, but if we take the absolute value of that, we get 2. And basically what we're trying to say here is that from -2 to 0 is a distance of 2 units. Now we can say, well, from 0 to 7 is 7 units, so 2 plus 7 equals 9 units of length. All right, so this is going to be 9. Next, we have something called the line segment addition postulate. And this postulate says that if we add pieces of a line together, we'll get the total line. Let's deconstruct that for a second. So in this example, we have from A to D, but we have checkpoints at B and C. So if I add AB, and I add BC, and I add CD, I will get the cumulative length of A to D. Right? I'll get the whole thing from A to D if I add up the different segments. So what is the length of AD in terms of x? Well, that means that we're going to need to add the different components up, and our answer will actually have the variable x in it. Well, let's see here. We have A to C is 2x plus 1. So I'm going to write that down here. From A all the way to C is 2x plus 1. B to C, interesting. B to C is x. And B to D, very interesting. B to D is 4x minus 1. What you can see here is we actually have a little bit of overlap. We have 2x plus 1 going from A to C, and then we have B to C as x, and then we have 4x minus 1 from B to D. We're counting this middle segment multiple times. So the segment addition postulate says that we only need to add each piece one time. So let's think about this. Well, 2x plus 1, it would be better if we just went from A to B. All right, so if we want to go from A to B, we would take 2x plus 1 and then subtract this overlap. So we have 2x plus 1 minus x will get us A to B. So another way to think about this is that from A to B, we would have 2x plus 1 minus x. If I substitute what those line segments used to be, that's like saying A to C minus B to C. So from A to B, I get 2x minus x, which is just 1x. Okay? And I have x plus 1. So I now have A to B. So A to B is just x plus 1. Now I have from B to D, I already know that. From B to D is 4x minus 1, so I can just simply add A to B and B to D to get the cumulative segment AD. So I will add our 4x minus 1. Okay, so 4x minus 1. Right, so 1 plus negative 1 gives me 0, and x plus 4x gives me 5x. So the cumulative length of line segment AD is 5x. If you draw yourself some diagrams like this, it'll make your life a little bit easier visually. Next on our road trip is to go from Austin, Texas to Houston, Texas. Oh, I just saw some cows roll past the road and some tumbleweeds because, yes, that's stereotypical Texas. We do have cows and we do have tumbleweeds, but they typically aren't on the road trip from Austin to Houston. But the reason why I mention Austin to Houston is because there's a little town called Brenham right in the middle. Some would even call it the midpoint of the road trip. So if we were going to take a road trip, you and I, from Austin, where I live, down to Houston, we would call Brenham the midpoint. All right, so Brenham is the midpoint. Now, how far is it to Brenham? I actually can't remember. But I do know, because I make this trip every once in a while to see my friends in Houston, that from Austin to Houston is 172 miles. I know that one. It's how much gas I have to buy and how long I'm in the car. It's 172 miles. Well, Brenham is the midpoint. In geometry, that's a really powerful statement. Knowing the midpoint means that it splits a line segment into two congruent pieces, meaning two equal pieces. So if 172 is the total trip, we would take 172 and divide it by 2 to get from Austin to Brenham. Because who knows? There's probably some cool stuff in Brenham, and I need to stop next time. Maybe just go to Brenham, give Brenham the credit that it's due as a small town. So 172, and I divide by 2, right? So there we go, that's 8 to give me 16. 12 remains, so 86, all right? So this is going to be 86 miles, and this is going to be 86 miles. Okay, let's apply that to a more conceptual geometric problem where I have line segment FH, where I'm told that G is the midpoint. So now we're going on a road trip to Geometryville. All right, we're going to find out FH. Well, what we're told is that FG is 5x minus 4, so this is 5x minus 4, and GH is 3x plus 2. So to find the length of FH, if we're trying to find the length of this line segment, what we need to do is set these two line segments equal to one another. Because G is the midpoint, meaning it bisects the line segment. A bisector is something that splits something into two pieces. So we have this two congruent pieces. We have this midpoint, G, and we're going to say that 5x minus 4, whatever that length is, has to be the exact same as GH, because G is the midpoint. Now we use some algebra. We'll subtract 3x from both sides. So whatever we do to one side, we need to do to the other. That leaves us with 2x. We haven't touched the minus 4 yet, equals 2. Next, we'll add 4 to both sides. Whatever we do to one side, we'll do to the other. And that will leave us with 2x equals 6, and then divide both sides by 2. So x equals 3. All right, well, that's not quite our full answer yet. We have x equaling 3, but we want to know the full line segment FH. So we'll input 3 as x. 3 times 3 is 9, plus 2 is 11. So GH is 11. And just to check our math, let's do FG as well. So we'll do 5 times 3 minus 4. 5 times 3 is 15, minus 4 is 11. Super. All right, so they are congruent. 11 and 11 makes 22. So FH equals 22 units. Hope you had fun measuring line segments today. Thanks.